Hello, my name is Kamal Reti, and this is a reconstruction of my solving day 4 of Advent of Code for 2022. It's reconstruction because I solved it in the morning under the covers in bed on an Android tablet. That's both hard to record and would be a very boring video if I did record it because I'm using the on-screen keyboard and typing on it is slow. But I'm now using the same Emacs version on my personal laptop, so I can make a recording of basically how I went about it. So I have already set up a template of the Emacs file, Advent of Code 2022 Day 4 EL, and in it I've got variables already set up. This is where the input data is going to go. This is where the sample input data is going to go. This require CL is because I use the loop macro and setf a lot. Some other common functions too. And so this is where I'm going to place the code for the part 1. And these are a couple of example invocations to call that function using the sample data and to call it with the input. And then here is the place to put the part 2 and similar calling functions. And I've already placed the puzzle, a browser with the puzzle. Notice over here I have an enunciator that shows the keystrokes that I'm typing, and it keeps them around for a while, and then they go away after a certain period of time. So today's puzzle, the story is that the elves have to clean up the camp before they can supplies can be unloaded from ships, and so the elves have these assignments for cleaning up, but they noticed that whoever given them the assignment had caused them to have overlapping assignments. So the elves got together in pairs, and each one of these lines is the assignment for 2 elves. The first is the first elf's assignment, and the second pair is the second elf's assignment, and they're inclusive ranges of sections that they have to clear. So this one is doing section 2 to 4 inclusive. This one is doing section 6 to 8 inclusive. And those two don't all overlap. But, for example, this one does. 5, 7, and 7, 9 both would clear 7, which is extra redundant work. And moreover, this one, the 6, 6 range is completely enclosed within the 4, 6 range. So they not overlap, but, you know, are sort of useless. Anyway, the puzzle data is this list of pairs of assignments. So I'm going to copy this. We will go off to this and put this as the sample data. And then we'll go back. And for each day you get input data. I've already loaded the input data. It's here, so I can just copy it, mark it all, select it all, copy it, and paste it in up here. Now, Control Meta E goes to the end of an expression, and then Control X, Control E evaluates the expression in front of the cursor. So I just evaluated it, and it defined that variable. And now, similarly, same thing here. And this allows me to actually test out things once I get to the point of having some code written. So just go back briefly. And I don't know why it didn't go back to the... Oh, here. Get rid of this. So the description, as sometimes happens in the Advent of Code, is a little bit long-winded. But in part 1, what they want you to do is they want you to count up for each pair of elves how many of those paired assignments are wholly contained in the other one. In other words, have either elf A doing totally duplicate work of elf B or vice versa. And so this is the A low number, the A high number. This is the elf B low number and the elf B high number. So basically what we have to do is we have to parse those 4 numbers, And then we have to do the comparison to see if one range is totally subsumed in the other range. So to no one's surprise, I'm going to use loop for that. And we want a couple of, so we're going to loop over all of the lines in the input string. So, but we need to separate those lines because input string is just a single string with new lines embedded. So loop for line in, this is going to be a list split string of input string, and I'm splitting a new line. White space would be the default if I didn't supply it. And now I'm going to want to have those 4 numbers. So I want the elf A low number, the elf A high number, the elf B low number, and the elf B high number. I'm going to get those as a list, and I'm going to make that list by using loop. And I need a couple of things for the duration of the loop. I'm going to use start as the variable of the index of where I'm going to look at the string that's the line for the number. And I'm going to keep around L as the length of the line, because I have to refer to that for each one. I'm going to only do this 4 times because I want 4 numbers. And then I'm going to collect into a list the result of parsing the numeric characters into a number. Now, there are functions that will do that, but I'm going to sort of unroll it and do it by hand. The reason for that is that way I get to skip over the extra punctuation between the numbers, sort of inside of this loop. Otherwise, I'd have to do some cumbersome stuff. So I'm going to loop with answer equals 0 for I from start. So our index into the line is going to start at start, but we're going to increment it for each number. For C, which is the character in that string, when I is less than L, that is, we haven't hit the end of the string yet, aref line I. So we're just getting the character out of that string. And we're going to turn it into a numeric digit. So for D equals when C, if we hadn't gotten a character, because we're at the end of the line, we obviously can't do this. And we're going to turn it into the digit, the numeric digit, by saying what position C is in this string. And we're only going to do this while we have a D, because, for example, when we hit the comma or the dash or the punctuation or the end of the line, we won't have a D. So if D is nil, then we're going to exit this loop. And each time through the loop, we're going to set Q the answer to be plus digit times answer 10, which means we're going to take whatever previous answer we had, multiply it by 10, and then add in the current digit. And then finally, at the end, we're going to do 2 things. One is we're going to increment start by 1 more than the number of digits we parsed into the answer. And so that's going to be minus current I, which is where we looked at the index that caused us to stop. Start, which is where we started. And then so we subtract those, and then we add 1. And so now start's going to point past all the digits we parsed, plus the extra delimiter. And then we're going to just return answer. So this is going to get us our 4 numbers. And now all we have to do is count according to the condition. And so the condition for part 1 is that the one range has to be wholly subsumed inside of another. And there's 2 ways that that can happen. We can say that AL, BL, BH, AH is always in a less than or equal to relationship. Or it could be the other way around, namely BL, AL, AH, BH is in that relationship. And then we're going to, that ends the loop, and that ends the defen. We compile it. Let's save just so in case something happens. So the way I usually do this is I do minus control meta at, which marks the previous expression in front of the cursor and copy it. And then I can do control U metacolon. Metacolon prompts for an expression to evaluate, but if you put a control U in front of it, it's going to insert the value. Yank that back in. And in fact, we get 2, which the puzzle says that in the sample input, there are 2 such pairs. So that's the right answer. So let's see what happens when we invoke that on the real input. Minus control meta at, meta W, control U, meta colon, control Y. We get the answer 500. And we scroll up, and indeed that was the answer I gave this morning, and that was the correct answer. So in part 2, what they want is they want you to basically count up now where there's any overlap at all. So the thing that's nice about this is that all of this code is exactly the same, except the condition here for counting is different. So instead of copying and pasting and changing the structure as I did in the last recreation, I'm just going to add an optional argument, part 2. Now optional arguments default to nil, so that means that part 2 won't be true if we just call it without that optional argument. So over here, I'm just going to say if part 2, and I'll have to add the part 2 condition. I'm just going to put this debug here as a placeholder. And reindent. So what's the part 2 condition? Well, the only ways that it can not be an overlap is if the high part of one range is strictly less than the low part of the other range. So there's 2 ways. So or less than AHBL or BHAL. So that is our control meta E to go to the end, control X, control E to compile it. Now, so what we need to do for the body here, since we are invoking this function, is we're just going to call the part 1 function, but with an extra argument. So we pass in the input string, but we add a T for the optional argument. And so that means when we call it this time, part 2 will be true, and we'll set it, control meta E to go to the end, control X, control E to define it, control X, control minus, control meta at, control U meta. So that tells us that the answer for the sample data is 4. Let's check that. Indeed, it is correct. And let's use it on the real data. Oops. I typed the wrong thing. And we get 815. Save it. And in fact, that is in fact the same answer I got this morning. So thank you very much for your attention. The 2 points that are of interest in this particular one are the fact that we can do both parts in the same function just by having this optional argument, and also that we don't have to rely on the built-in functions for parsing the numbers. We can do the parsing and the extra skipping of stuff. If the delimiters hadn't been just single characters, we could have scanned forward in the string to find the new value for start. Inside of here, we have lots of options. So thanks for your attention.